Welcome to my channel, where I'll be sharing tips and tricks. Don't forget to hit that subscribe button so you never miss a video.
Okay. Good morning, good afternoon, good evening, viewers. Depending on the time you are watching us on YouTube, please don't forget to subscribe to our YouTube channel. This is D.A.P Mathematics Center. Today we are going to look at rounding off of numbers and estimation. Rounding off of numbers and estimation. But before we take a look at the main topic, we are first of all going to look at the sub ones, which is names of commas in numbers and name of digits in position. We are first of all going to look at the sub ones, which is name of commas in numbers and name of digits in position. Now let's take the first one. Now, whenever time we are having more than 3 digits, which forms numbers, there must be a punctuation. Whenever time we are having more than 3 digits, which form numbers, then it means there must be a punctuation. Let's take for instance, if I am having 26352. These digits which are brought together to form numbers are more than 3, and henceforth, since they are more than 3, then there must be a punctuation elsewhere. Now, how can I come out with that punctuation? Before you can come out with that punctuation, then you need to check whether there is a decimal point or there is no decimal point. Now, when you come here, there is no decimal point. So if there is no decimal point, then in this case, we start from the right hand side to the left hand side. We start counting from the right hand side to the left hand side. So when I come to this, I'm going to have 1, 2, 3. Then there will be that punctuation here. Now, since the rest of the digits are less than 4, I will leave it like this. But if I'm having, for instance, 2, 7, 8, 5, 4, 6, 2, 3, 4, 7. Then, since there is no decimal point in this, I'm also going to start from the right hand side to the left hand side. So in this case, I will be having 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. Now, when I look at the rest, since they are also less than 3, I am going to maintain it like this. Now, all these punctuations which are shown over here are replacing certain things. Now, what are they replacing? They are replacing some names, and those names are what we are going to talk about. Now, whenever time you see a first punctuation in numbers, it has a name. When you continue in terms of getting the second punctuation, it also has a name which is different from the first one. When you continue further to get third one, it is also having a name which is also different from the 2 commas. So in this case, let's come out with those names. Okay, so when you come to the names of the punctuation that I was talking about. These are the names that we should know. Now, when you come to the first comma, it is named 1000. So if I'm having, for instance, 2, 3, 4, 7, 8, and if I am to locate where that punctuation is, in terms of counting from the right hand side to the left hand side, I'm going to have 1, 2, 3, comma. Then it means that this comma which is here, since it is the first comma to come in those numbers, then that comma is referring to as 1000. So in this case, if I'm to pronounce this, I'm going to have 23,478. 23,478. Now if I come to the second comma, then that second comma is named million. So if I continue on the number by having 2, 6, 7, 8. Now let's find where our comma is located. I'm going to recount by having 1, 2, 3, comma, 1, 2, 3, comma. Now since the rest of the digits are less than 4, then in this case, I am going to have the first one to be 1000, then the last one over here, since it is the second comma to appear, then that one is referred to as million. So in this case, if I'm to come out with the name or the pronunciation of the figures, then in this case I'm going to have 234,782,678. So when you come to the third punctuation, or the third comma, it is also known as billion. When you come to the fourth comma, it is known as trillion. When you come to the fifth, it is known as quadrillion. When you come to the sixth comma, it is known as quintillion. And when you come to the seventh comma, it is also known as sextillion. And many more. Now, these are the common ones that you should know. So we are going to use this in the main topic. But before then, let's take a look of the second sub-topic. Now we are taking the second subtopic, which says that names of digits in position. Names of digits in position. Remember that all these that we are doing are without decimals. Now when you come to name of digits in position, every digit has a name, especially when they are brought together to form numbers. So for instance, if I'm having 2, 3, 4, 7, 2, 8. Now that we know how to locate the punctuations, we are now going to look at the names. Now when you come to this side, starting from the right hand side, the 8 is the first digit to start. So it is in the first position, followed by 2, which is also in second position, followed by 7, third position, fourth position, fifth position, and the last position. Now, how do we come out with their names? To come out with their names, since there is no decimal point, we also start from the right hand side to the left hand side. Now, don't learn to memorize their names. To be able to get their names, it is very easy. So in this case, I'm going to start from the right hand side to the left hand side. So since I'm starting from the right hand side to the left hand side, this is my first digit. So I'm going to write 1 for the first digit. So if this is 1 for the first digit, then in this case, I'm going to have this to be ones or units, because unit means 1. Now when I come to the second digit, the simple trick is you keep on adding zeros to get the rest of the digits name. So in this case, to get a second digit, I'm going to add 0 to the 1. So this side, per the pronunciation of this one, will tell me the name of this. So in this case, this is pronounced 10. Then it means I'm going to have this to be 10 or tens. When I come to the next part, I keep on adding 0. So I'm going to have 100. So this becomes 100. When I come to the next part, I'm going to add 0 to it. Now, how name will be given to the 4? Now, to get a name, now remember that we said when digits are brought together to form numbers, then it means there must be a punctuation. And remember also that we did the names of those punctuations. Now, coming to this side, it has now exceeded more than 3 digits. So when I come to this side, I am going to find where that punctuation is located. So I will be having 1, 2, 3. It means that punctuation is located at this side. So if it is located at this side, then it means that I'm going to have this to be 1000. 1000. We are just looking for the name. So in this case, this becomes 1000. Then I come to the next digit. Now to know the name, I keep on adding 0. Now, whenever time you keep on adding 0 and there's a punctuation, they also varies. They also change from where they are being positioned. So when you come here, this punctuation will change from its previous position. Then we recount. So I'm going to have 1, 2, 3. So the punctuation will be here. This time around, I'm going to have 10,000. Since it is the first punctuation which is still existing. So in this case, I'm going to have 10,000. So in this case, here is going to be 10 of 1000. thousand. So in this case, the tray over here is known as tens of thousand or 10,000. Then we come to the last part. Now to know the last part, you keep on adding zero. The punctuation will change from 8th position. We recount 1, 2, 3, comma. 1, 2, 3. Now, since these digits are also less than 4, it is going to be remained like this. So in this case, I will be having 100. And then it is the same punctuation which is still existing. So this is going to be 100,000. So I'm going to have this to be 100,000. Please, I hope it is very, very easy now. Now, let's assume we are going to have more than 1, 2, 3, 4, 5, 6 digits. Let's assume we are going to have more than 6 digits. Okay, so we are going to take a look at this. And when you look at it, it is more than the first example that we took. The digits are more than the first example that we took. So in this case, let's continue on finding their names. When you come to this side, since there is no decimal point, we start from the right hand side to the left hand side. So here, I'm going to have my ones or units, which to know it's easy, I'm going to have my 1 over here. Then to know the name for the second one, you keep on adding 0. So this is going to give me tens. Then you come to the third one, keep on adding 0, means this is going to give me 100. Now we come to the next digit, keep on adding 0. Now that the digits are more than 3, we are going to find where our punctuation is located. So I'll be having 1, 2, 3. My comma will be here. And the name of this punctuation is 1000. So I'm going to have 1000 or 1000. Then you come to this side. Remember that the position of the punctuation all the time varies. It keeps on changing whilst we keep on adding zeros. So if I add 0, now I'm going to recount by having 1, 2, 3, comma. So it is the first comma which is still existing since the rest of the digits are less than 4. So here I'm going to have tens of thousand. Or 10,000. Then I come to the next part. To know the name, I keep on adding 0. So here I'm going to have 1, 2, 3, comma, 1, 2, 3. Since it is not greater than 3, I'm going to have this side to be 100,000. Now I come to this side. I keep on adding 0. So I'm now going to have 1, 2, 3, comma, 1, 2, 3, comma. Now, we've reached at the point of which the second comma is existing. So now we lose focus on the first punctuation. Now our focus comes on the second punctuation. So the name for this second punctuation, which we've already done, is million. So I'm now going to have millions or 1 million. Please, I hope I'm clear. Then we come to the next part. To know the name, you keep on adding 0. The position will keep on changing. 1, 2, 3, comma, 1, 2, 3, comma. Now I'm going to have 10. So the next thing is to know the second punctuation, the name of the second punctuation. Now this place is 10. Now what is the name of this second punctuation? Million. So I'm going to have tens of million or 10 million. Then you come to the next part. You're going to add 0. So to know the name, I'm going to have 1, 2, 3, comma, 1, 2, 3, comma. So since these digits are not greater than 3, I am going to have 100 million or hundreds of million. Then I come to the last part. Now when you come to the last part, I keep on adding 0. So here I'm going to have 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. Now we've gotten at the point where the 3 punctuation will also be existing. So this side we lose focus on the 2 punctuation. Now our focus comes on the 3rd punctuation. So this is going to give us billion. Please, I hope it is very, very easy for you now. So now this is what you must know before you get to the main topic. Now that we know this, let us now get to our main topic. Okay, so now we are going to look at the main topic. We've already looking at the sub ones. We are going to combine them to solve the issue of the main topic. Now let's take example on the main topic. Okay, so now this is an example on rounding off or approximation. So when you come to this side, it says that round off or approximate 6 to 6, 7, 2, 8, 5, 6 to the nearest. Approximate 6 to 6, 7, 2, 8, 5, 6 to the nearest. Now let's identify our punctuation in these numbers. 1, 2, 3, comma, 1, 2, 3, comma. So now that we have our punctuation, how are we going to pronounce these numbers? It means that Since I'm having the first punctuation to be thousand, this becomes million. So now I'm going to have 62,672,856 to the nearest. So approximate 62,672,856 to the nearest. To the nearest what? To the nearest tens, thousands, hundreds, and millions. Now, remember also that all these that we are doing are without decimal points. Let's rewrite our numbers. So I'm going to have 6, 2, 6, 7, 2, 8, 5, 6, which is 62,672,856. So we are going to round these numbers to their nearest or to its nearest. Now let's start with the first one. To the nearest tens. To round these numbers to the nearest tens, we need to look for the digit whose name is tens. So in this case, we've already done that whenever time there is no decimal point, we start from the right hand side to the left hand side. So here, I'm going to have this side to be ones. This side is going to be my tens. So now that I have this to be my tens, I'm going to write the digit that comes before the tenth digit. So I will be having 6, 2, 6, 7, 2, 8. Now that I have written those digits, I'm now going to check the digit that comes after the 10th digit. That is it greater than 4 or less than 5? Now that I've written the digit that comes before the 10th digit, I'm now going to check the number or the digit that also comes after the 10th digit. That is it greater than 4 or less than 5? Now this is the reason. Whenever time it is greater than 4, we round 1 from that figure and add it to the 10th digit or the digit whose name is pronounced. If it is less than, then we maintain that digit. So when you come to this side, since the digit which comes after the 10th digit is greater than 4, I'm going to round 1 from it and add it to the 10th digit. So in this case, I will be having 6. Now after doing this, since there is no decimal point, it has when to come out with the 0. Since there is no decimal point, I'm going to change this to 0 and add it to the number. Now we are done with the I. Now let's take the II. The II also says that we should approximate it to the nearest thousand. So in this case, I'm going to have, this time around it is not the 10th digit. This time around we are going to find our thousandth digit. So in this case, I'm going to have ones, tens, hundred, and then my thousand. So now this is my thousand. Now that I've identified my thousand, I'm going to rewrite the numbers that comes before the thousandth digit. So I will be having 6267. After rewriting those numbers, then I check the digit that comes after the thousandth digit, not the numbers, the digit that comes after the thousandth digit. That is it greater than 4 or less than 5? And henceforth we can see that it is greater than 4. So if it is greater than 4, then we are going to round 1 from 8 and add it to the thousandth digit. So I will be having 3. So now that I've gotten 3, the rest of the numbers changes to 0. So I'm going to have 0, 0, 0. Hope by now you've gotten the trick. Now let's come to I. So the I am going to have to the nearest 100. So I will be having ones, tens, 100. So this is my 100 digit. So now that I have my 100 digits, I'm going to have 6, 2, 6, 7, 2, 9. Then this one changes to 0, 0. So I'm going to have 0, 0. Now let's come to the IV. It says that we should run it to the nearest millions. So to the nearest millions, I'm going to have ones, tens, 100, 1,000, tens of thousands, hundreds of thousands. Then this becomes my million. So now that I have this to be my million, I'm going to round off. So I will be having 6, 3, then the rest changes to 0, 0, 0, 0, 0, which is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 means I have to add another 0. Please, I hope it is very, very easy now. Now let's take the one with decimals. Okay. Now when you come to the one with decimals, it also has its own way of representing or doing it. Now when you take the first one that we took, it was not ending with TH. It was rather ending with S. Now taking the first one, we have 10. And taking the IV, we have tens. Now what are the differences? Whenever time we are having decimals in 8, the name changes from tens to 10. If there is no decimal point in it, then the name changes from tenth to tens. Please, I hope I'm clear. So whenever time we are having decimal point, we never say tenth, we rather say tens. That's whenever time there is no decimal point. But if there is a decimal point, then we never say tens, we rather say tenths. It depends. You can also be meeting tens when decimal points are also existing in the numbers. Now let's learn how to go by such an example. Now when you take the first one, before we look at it, let's first of all name the position of decimal numbers and non-decimal numbers. Now when I take 23.468, the digit that comes before the decimal point are known as whole numbers. Or whole values. if I take the numbers that comes after the decimal point, they are known as decimal value. Please, I hope you can see from the board. Alright. So when you come to the numbers which comes before the decimal point, they are known as whole numbers. And when you come to the numbers which comes after the decimal point, they are known as decimal values. Now when you come to the decimal values, the side of the decimal values, when we are to know their names, we start from the left hand side to the right hand side. When we come to the decimal values, they are the one which the tens, the hundred will be ending with TH. So if it ends with TH, then it means that they are not talking about the numbers that comes before the decimal point. Whenever time you see this, then it means that they are not talking about the numbers that comes before the decimal point. They are rather talking about the decimal values. And when you come to the decimal values, to identify this, we start from the left hand side to the right hand side. But when there is a decimal point in those numbers, and yet they've given you tens, then this should tell you that they are not talking about the decimal values. They are rather talking about the numbers that comes before the decimal point, which is the whole numbers. Please, I hope you've gotten it. Good. So let's take the examples, then we will know how to answer such questions. Okay. Now when you come to the example, it says that approximate 23,206.72856 to the nearest I, tenth. So in this case, I'm going to rewrite the figures, which is going to be 3,226.72856. Now when you come to figures like this, we pronounce the digit that comes before the decimal point as 2,326. Then the one which comes after the decimal point, which are also known as the decimal values, as 72856. We never say 72,000, no. It is rather 72856. Alright. Now let's run it to the nearest tenth. Now since this one is ending with TH, we are going to focus on the left hand side. Since this one is ending with TH, we are going to focus on the decimal values. And you are being told that whenever time it ends with TH, that we focus on the left hand side, we start from the left hand to the right hand side. So here, I'm going to look for my tenth at the decimal values side. So now I'm going to find my tenth digit in the decimal values. When you come to the tenth digit, how do we find it in the decimal values? To be able to get it, bear in mind that we don't have ones in decimal digits. So when you come here, I'm going to start from tenth. So this is my tenth digit. Remember that I said we don't have one in the decimal values. So when you come here, I'm going to have the first decimal value to be tenth. Now, remember also that tenth is the same as 1 decimal place. Or value. Tenth is the same as 1 decimal place or value. When you come here, we have 1 decimal place, 2 decimal place, 3 decimal place, 4 decimal place, 5 decimal place. So this is the same as tenth. This is the same as hundredth, the one which ends with th. So when you come here, it says that we should run it to the nearest tenth. Now I've identified my tenth, so I'm going to have 2, 3, 2, 6 points. Then I check the number which comes after the first decimal value. That is it greater or less? And when you look at it, it is less. So in this case, I will maintain the 10th digit. So I'm going to have 7. Now, if it was to be without 0, then we would have added the zeros by changing all these ones. If it is without decimal point, then we would have changed all these to zeros and then add it to this. But since it is with a decimal point, decimal means fifth. So in this case, we are not going to change all these values to 0 and add it. No, we pause at where they tell us to look for. So when you come here, it says that we should look for the 10th digit. Now this is my 10th digit, so I pause there. Alright. Now let's come to the next example. So this is my I. Now when you come to the I, it says that to the nearest thousandth. So I'm going to look for my thousandth in these figures. Now which side? It is going to be on the decimal values. So I'm going to have tenth, hundred, thousand. So this is my thousandth. So I will be having 2, 3, 2, 6, which is 23,206.72. Then I look at the digit which comes after the thousandth digit. So when you look at it, it is greater. So I will run 1 from 8 and add it to this. So I'm going to have 9. So since there's a decimal point, it tells us that it should be fixed. Now let's come to the I. When you come to the I, it says that to the nearest 100. So it will also fall on the decimal values since it is ending with th. So I'm going to have 10, 100. So this is my 100. So I will be having 23,206.73. I hope now it is very, very easy for you. Then I come to the next part, IV. IV says that we should run it to the nearest tens. This time around, it is not ending with th, it is ending with x. So if it is ending with x, then my focus should not be on the decimal values. It should now be on the whole numbers. So in this case, I'm going to find my tens. Now when you come here, from this side to this side, there is no decimal point. So I start from this side. Here is going to be my ones. Here is going to be my tens. So this is my tens digit. So this time around, to the nearest tens, I'm going to have 2, 3. Then I check, it is greater. So I'll run 1 from this to that. So I'll be having 3, then 0. Please, I hope you've seen it. Very, very easy. Good. Now let's come to the next part. It says to the nearest hundreds. So to the nearest hundreds, it is also not ending with th. So I need to look for my hundreds, taking the whole value. So in this case, when you come to the whole numbers, I'm going to have ones, tens, hundreds. So there's my hundredth digit. So I will now be having 2. Now, since it is less, I'm going to maintain it, so I will still be having 3. Then the rest change to 0, 0. Please, I hope it is very, very easy now. Now, let's take the next part. Okay. Now, our next looking at is significant figures. Significant figures. Now, what is the meaning of significance? When we say significant, I'm sure you know that it is also the same as important. Now, if significant means important, then this should tell you that we are going to look at figures which are important. Now, some figures become important due to their position. For instance, if I'm having 0, 1, this time around, this 0 over here has nothing to do. In this case, this is the same as 1. So we say that 0 is not significant or important. Now, whenever time 0 starts before natural numbers, we say that those zeros are not important. On the other side, if I'm having 1, 0, 0, 0, when you come to this side, there is no decimal point. Since there is no decimal point and we are having 0 to be the ending after the natural number, we also say that these zeros are not important. But whenever time zeros are between natural numbers, then this time around we say that 0 is important. For instance, if I'm having 1, 0, 1, then we say that this 0 over here is important. Now let's take examples on significant figures without decimals. Alright, now when you come here, it says that approximate 2,678,346 to the nearest of 3 significant figure. It says that approximate 2,678,346 to the nearest of 3 significant figures. Now, how do we go by this? Now, let's rewrite the figures. So, I'm going to have 2, 6, 7, 8, 3, 4, 6. And it says that we should run it to the nearest 3 significant figures. So here, I'm going to find those 3 important figures. Now, every natural numbers are important. So when you come here, all these are natural numbers. So in this case, I'm going to have my 1 significant figure, 2 significant figure, and 3 significant figure. So in this case, I pause here. So when you come to this side, since I have been able to identify my 1, 2, and 3, I am going to rewrite them. So I will be having 2, 6. Now, what is here? 3. It means that when you get to the third important figure, there's something you should do. So when I come to this side, I have my first, second, and then the third. So this is my third significant figure. So since this is my third significant figure, I am going to round this number since it is greater than 4. So I will now be having 8. Now if I get 8, I'm going to change the rest to zeros since there is no decimal point. So I will be having 0, 0, 0, 0. Please, I hope it is very, very easy now. Now let's take another example. Okay. Now taking the next example, it says that approximate 2,678,346 to the nearest of 2 significant figures, 4 significant figures, and 1 significant figure. So now how are we going to do this? So we are going to take the first one. It says 2. So I will be having 2, 6, 7, 8, 3, 4, 6. I have rewrite the figures. So now that I've done this, I'm now going to have, where is my first significant? Is it important? Yes, it is natural number, so it is important. So I'm going to have 2. Now they said 2 significant figure. It means when I get to my second or the 2 significant figure, there's something I should do. So I'm going to check the number that comes after that 2 significant figure, that is it greater or less. Now henceforth it is greater. So in this case I'm going to have 7. Then I change the rest of the digit to 0 since there is no decimal point. So I'll be having 0, 0, 0, 0, which is 1, 2, 3, 4. So this is what I suppose to get. So now I've round 2,678,346 to the nearest 2 significant figure. Now let's take the next part. It says 4 significant figure. So here I'm going to have 1, 2, 3, 4. So that is my 4 significant figure. So I'm going to have 2, 6, 7. Then since this one is less, I'm going to have the same 8. Then the rest changes to 0. Now I come to the next part, I. It says to 1 significant figure. So 1 significant figure, there is it. So in this case, I will be having, since it is greater, I'm going to have 3. Then 1, 2, 3, 4, 5, 6. So the rest will change to 0. Now after doing this, then I notify them that this is in 2 significant figure. This is in 1, 2, 3, 4. So 4 significant figure. This is in 1 significant figure. Please guess it is very, very simple. In case there's something bothering you, please leave it at the comments section and I will answer you. Now let's come to the next part. Okay, so now when you come here, this is significant figure with decimals. So on this side, it says that we should approximate 26.78346 to the nearest of I. 3 significant figure, 2 significant figure, 4 significant figures, and then 5 significant figures. Now, when you come to this type of an example, it is not having 0. We'll be taking them one after the other. So when you come here, I'm going to rewrite by having 26.78346. Now let's find the first one. It says that to 3 significant figure. So I'm going to have I. to 3 significant figures. Now, all natural numbers are important. So when you come here, it is important, it is important, it is important. So I'm going to have 2, 6 points. When I get here, I have to do something. So here I'm going to have my 8. Now, bear in mind, whenever time zeros comes, whenever time there is a decimal point. Now, bear in mind, whenever time there is a decimal point, we've already been told that it is fixed. So when I come to this side, I'm going to have 26.8, which tells me that it is important, it is important, it is important. So it is in 3 significant figures. Then I come to the II. It says that to 2 significant figures. So here I'm going to have 2. Now, there's my first, there's my second. So since this one is my second, I am going to round. So I will be having 7. Now, since this is in 2 significant figures, I'm going to have 2 significant figures. Remember that this is the same as to the nearest whole number. Why? Because there is no decimal point. Now let's come to the III. The II says that to 4 significant figures. So here I'm going to have first, second, third, fourth. So this is my 4th significant figure. So I'm going to have 26.78. Why the same 8? Because it is less. 1, 2, 3, 4. So I'm now going to have 4 significant figures. Please, I hope it is very, very easy now. Now let's come to the final one. Now the last one says that to 5 significant figures. So I'm going to have 1, 2, 3, 4, 5. So this is my 5 significant figure. I'm going to have 26.78. It's also going to be the same thing, which is 3. So I'm now going to have 5 significant figures. Please, I hope now you've well understood. Let's take more examples. Now, this is our last example on significant figures with decimals. Now, when you come here, it says that approximate 0.0240020 to the nearest of 1 significant figure, 3 significant figure, and 5 significant figures. Now, how do we go by this? What are significant figures? We defined it earlier on that they are numbers which deals with only the natural one. Now, what are natural numbers? They are numbers that starts from 1. But on the other side, whenever times zeros are between natural numbers, then we take that 0 as significant figure. Whenever time there is also a decimal point, which the zeros are ending, then we also classify those zeros as significant figures. But when zeros are starting, both with decimals or without decimals, then we say that those zeros are not significant figures. Now let's come to this side. Since I'm having 0.02400,200, it says that we should run it to the nearest 1 significant figure. So here, I'm going to have this, I'm going to have this. Since 0 is starting, then in this case, they are not significant figures. And remember, when there's a decimal point and it is also ending with zeros, then those zeros are significant figures. Also, when zeros are between natural numbers, then we say that those zeros are also significant figures. So when you come here to one significant figure, I'm going to have 0.02. So it is not important, it is not significant, it is significant. Now when you come here, it is less than, so in this case, I will have the same 2. So this is in one significant figure. Now let's come to the next part. To trace significant figure. Now to trace significant figures, I'm going to have not significant, not significant, 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 significant. Why? Because they are between natural numbers. So in this case, I'm going to have 1, 2, it says 3. So I'm going to have 1, 2, 3. So in this case, I will be having 0.0. These are not significant. So in this case, I'm going to have 1, 2, 3. So I will be having 2, 4, 0. So now I've gotten this, I'm now going to have 3 significant figures. Now, at this point, this 0 which is ending over here, the 0 which is ending over here, on the other side, you can choose not to, but please I will advise you to write them. Alright, now let's come to the next part. When you come to the next part, which is the last one, it says that to 5 significant figure. So if to 5 significant figure, then I'm going to have, it is, so 1, 2, 3, 4, 5. So the 5 will be ending on this. So 1, 2, 3, 4, 5. So in this case, I'm going to have 0.024002. So this one is also in 5 significant figures. I hope by now you've well understood. Now let's take the next part. Okay. Now when you come to this side, we've combined everything. Are you getting it? Good. It says that approximate 2,998 to the nearest I, tens and then hundreds. Now, per all that we did, there wasn't any 9 digits existing in them. So in this case, we are now coming to the 9 digits. Now, how do we run or how do we approximate digits which contains 9? Now, when you come to this side, all the time, the left last digit takes a maximum of infinity figures. Are you getting it? So in this case, it says that we should run it to the nearest tens. Now let's rewrite it. So I'm going to have 2998, which is I. Says that to the nearest tens. So I'm going to identify my tens. So this is going to be my ones, and then this is my tens. Now that I've been able to identify my tens, I am not going to be in hurry to write the digits over here. No, look. I'm rather first of all going to round it. Now look at something over here. This is 9. If the digit is to be less than 9, then in this case, I will rewrite before I round. But since it is 9, I am going to round it before I write the digit that comes before the tens digit. So here I will be having If I run it, I'm going to have this to be 10. But mind you, I said that all the time, the last left digit takes every maximum. Are you getting it? So when you come to this side, I am not going to get the 10 at this place. So in this case, I will clean the 1, then it will be remaining 0. So I'm going to move the 1 to this. So this one will also change to 10, which I'm not interested. I will continue cleaning the 1. Then I move it, so here becomes 3. So in this case, I'm going to have 3. Then I change the rest to 0, 0, 0, which these are already in their zeros. So I'm going to have 0, 0, 0. Please, I hope it is very, very simple. Now let's come to the next part. The next part also says that we should run it to the nearest hundreds. So hundreds, I'm going to have, let me write it, 2998. So now that I have my 2998, to the nearest hundreds, I'm going to have 1 times 100. Now, I have to run it, so I'm going to have this side to be 10, which I'm not interested. I'll clean the 1, bring it here, so I'm going to have 3, 0. Then I change the rest to 0, 0. So 1, 2, 3, 1, 2, 3. So this is what I supposed to get. Remember that this is the same as running it to the nearest one significant figure. This is also the same as running it to one significant figure. The decimal point also takes the same procedure. Now let's take the one with decimal points. Alright, so now when you come to the next example, it says that we should approximate 2.998 to the nearest tenths, hundredths, ones, and then whole number. So how are we going to do this? Now let's rewrite the figures. So I'm going to have 2.998. Now the first one says to the nearest tenth. You already know that, is that not it? So here I'm going to have, let's identify the tenth digit. We start from the decimal values. We don't have ones in decimal values. So this is going to be tenth. So this is my tenth. Now that I have my tenth to be 9, I have to take my time. I don't have to rush to write the figure that comes before the decimal point. So now that I have it, I'm now going to round the number and add it to this. So it will be 10. Now we are not interested of 10 at this place, so I'll take off my 1, bring it here. So now that I have here to be 3, I'm now going to have this side to be 0. Since there's a decimal point, it needs to be faced. So here is my whole number. This becomes my 10th digit. The rest remains still. Now let's get to the II. Now the II says that to the nearest hundred. So here I'm going to have, let me rewrite it, 998. So I'm going to have 10th hundred. So this is my 100 digit. So now I'm going to have this 9 to be my 100 digit. So I'll run. So here is going to be 0. I'll move the 1. It's supposed to be 10, which I will not be writing it. I will move the 1. This one will also be 10. I will not be writing it. I will continue moving the 1 until it gets to the last position on the left hand side. So I'm going to have this side to be 3. Then 0.00. So since there's a decimal point, I'm going to leave this one. So now it is in tenth and then 100 digits. Please, I hope you've well understood. Now let's take the next one. Now when you come here, it says to the nearest ones. Now to the nearest one, this is not ending with th, and I've already informed you that. So in this case, I am going to start from the digit of whole numbers. So here, if it is 2, this is 1. So I'll be having only 2. Now let's come to the last one. Now when you come to the last one, it says that to the nearest whole number. Now to the nearest whole number, I'm going to have this side. Let me rewrite. I'm going to have 2.998. So to the nearest whole number, I have to check the number over here. Now with the ones, I don't have to. Are you getting it? With the ones, I have to write only the number which does not fall on the decimal values. But here it says that whole number. So if whole number, then I'm going to have this part to be 3. Please, I hope you've well understood. Very, very easy. Now let's take our last point, which is estimation. Alright, now what is an estimation? When we say estimation, they are the approximated figures which are used in calculation, or they are the approximated figures which are used in calculation. We say that estimation, they are the approximated figures which are used in calculation, or they are the rounded figures which are used in approximation. Now let's take example on that. Okay, now this is an example on estimation. Now when you come to this side, it says that by approximating each value to the nearest tenth, estimate the following. Estimate the following. Now let's start with the first example. Now it says that we should estimate the following. So here I'm going to have 9 points, rewriting it, 89 plus 8.233. Now when you come to this side, what am I going to have? The first thing that I need to know is what is an estimation. It says that they are the approximated figures. So it means that I have to approximate it before I simplify or get to the calculation. So here I'm going to round it to the nearest tenth. So each value. So it says that each value. So I'm going to have, since I'm having 9.89 to its nearest tenth is going to be, this is my tenth. So I will be having 9.9 plus, when you come to this side, to the nearest tenth, 2 is the tenth. So I'm going to have 8.2. So now, since I have approximated it, I can now calculate it. So this is what we refer to as estimation. So coming to this side, I'm going to have 9.9 plus 8.2. I guess by now you know how to do this. Now let's take a recap. So when you come to this, I'm going to have 9.9 plus 8.2. 8.2. So when you come to this side, I'm going to have 9 plus this will be giving me 11. Now this 11, I'm going to write remainder 1, quotient 1. Now most of you, whenever time you are dealing with this, you rather write 1, remainder 1. No, it is rather 1, quotient 1. I'm going to add the 1 to this, making 10. Now 10 plus 8 is going to be 18. So in this case, I'll bring my points here. which I'll be having this side to be 18. Very, very simple. So in this case, when you come to this side, I'm going to have 18.1. Now let's take our second example. Now when you come to this side, it says that we should approximate 20.4 minus 8.98 to the nearest tenth. It says each. So in this case, I'm going to approximate it before this. So I'm going to have to approximate this to the nearest tenth. This is my tenth, so I'll be having the same 20.4 minus this is my tenth. So since this is my tenth, I have to run it will be 10. I'm not interested of 10, I'll write 0. Then I move the 1. So here I'm going to have 9.0. Please, I hope I'm clear. So now that I've gotten my 9.0, I'm now going to evaluate it or simplify it. So here I'm going to have 20.4 minus 9.0. Now let's do break. So here I'm going to have 20.4 minus 9.0. So coming to this side, I'm going to have here to be 4. Then I'm going to have 20 minus 9, which is going to give me 11. So finally, I will be having 11.4. So now let's take the last example. Now when you come here, it says that we should approximate the value of 2.9 times 39.5. So I'm now going to have to the nearest tenth, which is the same as 2.9 times 39 to the nearest tenth, which is going to be 6. Now we are going to estimate this or evaluate this. So evaluating it, I'm going to have 396 times 29. Whenever time you are dealing with multiplication of decimals, make sure you take away the decimal point. So here I'm going to have 9 times 6, which is going to give me 54. I'm going to have my 4, quotient 5. There is the remainder, quotient 5. Most of times what we say is 4 remainder 5. No, it is rather 4 quotient 5. So in this case, I'm now going to have 9 times 9, which is going to give me 81, plus this, which is going to give me 86. So in this case, I'm going to have my 6, then quotient 8. So I'm now going to have 9 times this, which is 27. 27 plus this, which is going to give me 35. So I'm going to have 35. Then I come to this side, 2, 6, 12. Now I'm going to trace. So I'll be writing it under this, which is going to be 2 quotient 1. Now I'm going to have 2, 9, 18 plus 1, 19. So I'm going to have my 9 quotient 1. Then I move on, 2, 3, 6 plus 1, 7. So I'm now going to have 7. Then I sum everything here. Here is 0. So I'm going to have 4 plus 0, which is going to give me 4. 6 plus 2, which is going to give me 8. 5 plus 9, which is going to give me 14. Now 14, I'm going to write 4 quotient 1. So after writing it, I'm now going to have 3 plus this, which is going to give me 10 plus 1, which is going to be 11. Now after doing this, then I count the numbers that comes after the decimal point. So I'm going to have 1, 2. So I'm now going to have 1, 2, which says that my decimal point will be here. So I'm now going to have 2.9 times 39.6 to be 114.84. Please, I hope you've well understood. In case you don't understand anything, make sure you prompt us at the comments section. Please don't forget to subscribe to our YouTube channel so that whenever time we upload new videos, you will get it. Thank you very much. May God bless you. Bye bye.